Well, good morning or afternoon, whatever time of day you're watching this. I am going to go through a quick example from the homework, just a very basic thing about how to find out the parts of the graph when you're given a quadratic function that they make those parabolas. So we're going to talk about how to find that vertex where it turns around, possible x-intercepts, what is the axis of symmetry and stuff like that. So I wanted to share with you a couple of things that you have access to. Well, the first thing I'm going to show you is what I posted this document in my math lab that you can download it and print it off. And it's got all the summary stuff. The first page is really about the parts of a graph and what the significance of the coordinates of the vertex would mean. We're going to be using stuff on this page when we're being asked either literally to find the vertex, or if we're going to be asked about where there's a maximum or minimum value for this function. Because you can see if it's one of those that faces downwards, then right there, the HK is the maximum. And then if it is facing upwards, then the vertex represents a minimum. So that's one of the significances of the vertex. The other thing is also just tells you where it's changing from increasing to decreasing or vice versa. Okay, so whenever we're asked about a maximum, or we're asked about a minimum, or asked about the vertex, or we're asked where it changes from decreasing to increasing or back and forth like that, all of those involve doing these calculations up here to find the X and Y value for the vertex. All right, then I give it a little example. The second, if you turn the paper over, or the second page, depending on how you print it out, is also, this is kind of what 3.2 is about, when you're having to set up and solve an equation for X, where the X squared is the largest power of X. So basically, if it has an X squared in it, you can rearrange it, pull all the terms to one side so that you have 0 on the right-hand side. And then we can solve that by, sometimes these numbers are pretty and it factors. And if they don't factor, we can always run it through this quadratic formula. Okay, now that's going to give us 2 points. It's going to give us 2 X values. So every time you have an X value, you can find the Y value that goes with it by plugging that number back in. So you'll have 2 points in 2 ordered pairs. So you're going to be using that technique to set up and solve an entire equation when you're being asked something about when does this function equal a certain number? Like when are the profits going to be $5,000? Something like that. When they give you a specific value, output value, they want you to figure out what input that will happen. Well, if you think about the shape of a parabola, whatever the value is, it'll hit it one time on the way up and then it turns and it hits it again on the way down, or vice versa. So that's why there's 2 areas that we look at. Okay, and then I do another example. Okay, so this is a sheet you can print off. You can put it in your notebook so that when you're taking Mod2 tests, you have these kind of shortcut summaries here, or you can just access it as you need it, or just use what you need in the problem. So let me go to the problem, show you what I'm going to be working on. Hello, share the screen. This. All right, so this was the problem that I was sent. I know I'm doing it for a specific student, but I'm also going to post this for the class so everybody can see it. So they're giving us this function here, and they ask us to do 4 things. They want to find the vertex, like calculate the coordinates for the vertex. We want to do the axis of symmetry. We want to determine whether there's a maximum or minimum value, and then we can find that maximum or minimum value and then graph the function. So we're going to do all that on a piece of paper, and then I'll come back and put the graph in over here. Okay, so let me stop sharing that and go to my notebook where I have this already ready to go. There we go. Okay, so what we have, I went ahead and just copied the same problem that was in the problem that was sent, but of course, everybody gets different randomly generated numbers. So the first thing is, this is going to have some kind of a parabola type of graph. And if we're thinking about axis of symmetry and maximum, we can actually tell that right now. When you look at the sign of your leading term, the term with the highest power of X, we call that the A value. So that would be A is 1, B is -10. C is 24. We'll need this for to answer some of these questions. Sorry, that says B equals -10. If your A value is positive, that means it's going to be a parabola that has your vertex. We have the special coordinates for that HK, and it's going to go upwards from there. That's also on that sheet of paper. So if your leading term is positive, it's going to go upward towards the positive y direction. If it had been negative x squared or negative 5x squared or something where the squared term is negative, then the vertex, it would be the top of the graph and it would open downwards towards the negative y value. All right, so first of all, in the vertex, there's a way to rearrange the equation, rearrange the function so that it's in what they call the vertex form. And I believe if you click on the view example, at least one of these problems, it has you go through all these algebraic techniques to rearrange this formula and take half the middle number and divide it by 2 and then square everything. You know, it's a kind of complicated thing. So there's a different way to do a vertex. I think I have it in one of the pop-up instructor tips, but this is how I recommend doing it. Okay, the vertex is this special point that lies on the graph. This is X, this is Y, we're calling them H and K. What I would do is just in step 1, we're just going to figure out these coordinates separately. So this is the formula to calculate the H value, negative B divided by 2A. Negative B divided by 2A. Okay, that's the first thing. Once we know H, we will use the H because that's just a specific X value. We'll just plug it back into the formula to find the Y value that goes with it, like we always do once we know what X is. All right, so for this problem, for our example, H is negative B. Well, B is already negative, negative 10. And then divided that by 2A, which is 2 times 1. All right, so that's going to give us positive 10 divided by 2. So 10 over 2 is 5. So H is 5. So our vertex is starting to take shape. It's going to be 5 something. Okay, so now let's find the rest of the vertex. So step 2, once you find H, now that you know H, plug H that you just figured out back into the function. So that function is just that expression for the X, and then work it out. That's your Y value. And that will be K. So K is just the Y value when X equals that H number. That's what I'm saying. All right, so instead of doing f of x, we have a specific input. We're going to do 5. So we're going to do f of 5. Move this up a little bit. Equals, and we'll do, instead of x squared minus 10x, we'll do, 5 squared minus 10 times 5, and then plus 24. All right, well, we can get our calculators to work this out if you'd rather. Let me see how I can do on my head. 25 minus 50 would be negative 25. Negative 25 plus 24 would be negative 1. Is that right? Negative 50 plus 24 would be negative 26 plus 20. Yeah. All right, so f of 5 equals negative 1. Okay, well, that's my K value right there. Remember these function statements? F of 5 equals negative 1 means the first number is your X value and what the function equals is your Y value. That's your vertex. So if I went back, I don't know why I'm going back up here. Like if I were going to answer it in my math lab, when X is 5 and Y is negative 1, we are on the vertex for this problem. Okay, so I know a couple of things already. Just in my head, I'm forming this picture. Over 5, down 1 for 5, negative 1. I know it's going to open upwards because the leading term was positive. So it's going to look something like this. Okay, so that's why they're asking us to find the x-intercepts, because the vertex is below the line, it's going to go upwards. Well, one of the other things about vertex or about parabolas is that they're symmetric with respect to this middle point. So if it's fairly steep on the left, once it hits that low point, it's going to have that same kind of steepness on the right. It won't be real steep here and then kind of flatten out on the other side. They're symmetric. So there's this kind of middle of the graph, which is halfway between both of these, I guess we call them arms that come up from the vertex. So if you had a point over here, you go to the middle, you go out the same distance the other side, you have this mirror image point. That vertical line is what we call the axis of symmetry. Okay, and all it is, the vertical line isn't part of the graph except for that one place in the vertex where it connects to the parabola. So the axis of symmetry is just a vertical line. And vertical lines always have equations like x equals wherever it's hitting the x-axis, because all of the points on that line would have the same x value. Well, the x value is going through the vertex, so it's 5. So the axis of symmetry I'll do this before I turn the page. Your axis of symmetry is just the equation x equals 5. But this is in the context of the equation of a vertical line, not a single point. So this would be a vertical line. This would be infinitely many points along that vertical line. So that's the axis in general. You just say let x equal h. So it's super easy. If you've already figured out the vertex, you can also take this number and identify the vertical line that's cutting it in half. All right, so we've done the vertex. Just do h and k separately. We've done the axis of symmetry, which is just let x equal h. Vertex is h is negative b over 2a. K is f of whatever you just figured out for h. I'm just kind of giving you some summary. This is all on that sheet of paper. Now, we can also answer this question before we do any graphing. Is the vertex going to represent a maximum or a minimum? Well, we've got a little idea now. We know it's 5, -1. So we know the vertex is below the x-axis. We know that it opens upward because it's positive. So yes, it's going to have a minimum value will be what the vertex is. So the maximum or minimum value, basically, it's going to be a minimum like this when your a value is positive. So I'm going to go and put a little extra note here. You have a max when a is negative, and you have a min when a is positive. All right, again, all of this is on the sheet. I'm just kind of cramming it on this one page. All right, so the last thing I want us to do is go to the, have we done the x-intercepts yet? Let me see, did they ask, I'm going to check and see if they asked us for x-intercepts. Determine the maximum, okay. They haven't talked about the x-intercepts, but that would be helpful to know to graph it. So let me go ahead and do that real quick, because that's also a 3.2. So we had x squared minus 10x plus 24. That's our function. Oh, wait. Oh, yeah, I'm still sharing. I just forgot which one it was. There we go. Okay, so we have this. And if we want to do the x-intercepts, that'll make it easy to graph with. Okay, x-intercepts, they're on the x-axis. So if they're on the x-axis, that's because the y value is 0. So on a problem like this, y is the same thing as the output f of x. So we're just going to set it equal to 0. Now, you were supposed to be solving this in previous courses, Algebra 1, maybe some Algebra 2, you solve some quadratic equations. I'm sure in the examples, they pop up lots of good ways to do it. The main ways are either factoring. If this is something that's able to be factored into 2 binomials like this, then you can use this property of zero product rule, I think, where you take each individual factor and set it equal to 0. There's going to be 2 answers on these. So there will usually, almost, unless it's the same value twice, but you'll get 2 solutions to a quadratic. Okay. So this would be if you solved it by factoring, which you can because it's going to be 6 and 4. You want something that when you FOIL it out, you're going to get these. So your last times last would be positive 24. And if you did your inner terms and your outer terms, they would add up to your 10x. I don't know if you remember that. Anyway, so if it factors like this, then what we would do is we would take each individual factor and set it equal to 0. And we would get these 2 x-intercepts. There's 2 of them. So really, we're talking about the point at 6, 0 and the point at 4, 0. Those are my x-intercepts. Okay, so now I've got this picture. Remember, we go out 5, down 1. There's my vertex. And it says I have an x-intercept at 4 and 6, right? So it's going to go that way. It's going to go up here like that. I'm not going to worry about figuring out the y-intercept because it's going to be way high. Whenever you have a polynomial like this is your y-intercept, always. If the expression like that. So it's going to, this is going to go way up here to 24 before it crosses the y-axis. So I'm just going to try to graph this idea on my MATLAB. So let's stop sharing this and let's go back to the grapher. Let me find, I want to share. Give me a minute. There we are. Share. Okay, so we're to the third. Let me go ahead. I guess I have to type all this in. So the vertex was, what was it? 5, -1, right? So this in there. 5, -1, get rid of that field. -1. Okay. The equation for the axis symmetry is always going to look like x equals, and what was the h value? 5. Because it's a vertical line, cuts through the middle of the graph. Every point on the graph has to have the same x value, and since 5, -1 is on that line, that's the x value that we're looking at. Together. Okay. All right, determine whether the parabola has a maximum or minimum and find its value. Well, this is interesting. I didn't write it on the paper, but this is a little bit of an interpretation thing. We talked about earlier that it's going to open upwards. So that means the vertex will represent a minimum. So part A, the parabola opens upwards and it has a minimum value of, okay, we've talked about this in Mod 1, but whenever they talk about a function value, we're talking about the y value. So the 5, -1 is going to be the lowest point, and it's going to go upward from there. So 5, -1 is right there. So the lowest value means the lowest y value. So it's going to have a minimum value of -1. That's your y value of the vertex. Okay, so now it wants us to graph it using the graphing tool on the right. Let's try it. It's going to be a parabola. So you pick your shape first, and then you follow the instructions. It says, I picked this parabola tool. There should be a place where it says pick your vertex. Where's my instructions? All right, I'm going to do it a different way. Let's go here. And I'm hoping that this popped up on your screen too. All right, so can I make this bigger? Guess not. All right, so I'm going to pick the parabola. Right here now I have the instructions at the top. Graph your vertex. So over 5, down 1, and make sure to watch the coordinates up there in the right. See, like right then I clicked on 5 and went down just 1 unit, but then I go look up at the corner there and it says that the units are split in half, that I'm at 5, -0.5. So I need to go down another unit. Now I do see that it lines up on the y-axis. 5, -1, right there, click. All right, now see how depending where I put a second point in, it's like a bird flying here. All right, anyway. Now it says, click on the graph to plot a point on your parabola. So now that we've got the vertex, let's just go back to one of those x-intercepts, right? It was 4, 0 or 6, 0. So I'll click on that one. All right, so let's save it, see how we did. All right, so that's a little summary of how you find the different pieces of the graph for a quadratic function, and a little preview about how to solve the equations if you need to find x-intercepts. So I hope that's helpful and that you can get all your quadratic stuff done over the weekend.